In this episode of KubeFM, we're joined by Alexandre Souza, who will dive deep into the challenge of configuring resources and limits in large-scale clusters, offering expert advice on avoiding over-provisioning and under-provisioning. He'll explore how tools like HPA and VPA can help scale resources efficiently while discussing the differences in managing CPU and memory in Kubernetes. We'll also cover autoscaling tools like Argo CD and Flux, and the role of automation in simplifying Kubernetes management. Whether you're scaling clusters or optimizing performance, this episode is definitely for you, so check it out. This episode of KubeFM was sponsored by Victoria Metrics. Try Victoria Metrics Enterprise for free today. With their Kubernetes operator, deploying a simple, scalable, open-source monitoring system is effortless. Experience advanced enterprise features such as downsampling, enhanced security, and automated backups. All right, Alex, so can you tell me about which 3 emerging Kubernetes tools you're keeping an eye on?
Yeah, absolutely, Bart. For me, one of the most important tools that I've been keeping an eye on and also getting up to date with, that's Kubernetes. Kubernetes is a tool that manages the life cycle of clusters nodes. So it helps you scale up and down as your needs demand, as your workload demand, and also can help you save money on on infrastructure. Another one is KubePlugins. KubePlugins, actually, Kube is a tool within the kubectl that allows you to install other very nice, helpful tools. So they have above like 260 different tools. Some of them overlapping, but some nice ones I like to keep in mind. KubeContext, Kubernetes that says shift namespaces when you're doing some debugging, troubleshooting. Resource capacity as well, give you some insights of the capacity within the cluster. For example, if you don't have KubeCost installed, resource capacity can help you a lot on that. View allocation is always really nice. And one very important thing where you're managing Kubernetes clusters is Kubernetes. Kubernetes is not part of KubePlugins, but you can install it separately. It's called a KubeNoTrouble. It allows you to inspect the APIs within your Kubernetes to verify what's it's going to become outdated in case you're migrating Kubernetes from one version to another. And two other nice tools is very important. They are in the same topic. It's to do active GitOps. One of them is Flux CD, and another one is Argo CD. They basically do the same thing. Of course, there's some different features here and there, but they're really nice when you want to bring GitOps to your organization.
Very good. Out of the two of them, do you have a preference, Flux versus Argo?
I prefer Flux because Flux has this Terraform operator, so I don't need to use something else to deal with Terraform. I know that Argo CD, for example, Flux were initially created for Kubernetes orchestration and rollout of package Kubernetes, object Kubernetes, but Flux comes with this Terraform where you can provision any other infrastructure on your cloud provider. Argo CD, I'm not sure. I heard they were doing something similar, but so far not. So currently I use Argo CD in my company, Getir, but we have to use another tool to deal with Terraform.
So you mentioned your company. Can you tell me more about what you do and who you work for?
Absolutely. I work for a company called Getir. Getir is a Turkish company, and they basically in Europe they are a quick delivery service. So they deliver grocery within like 20 minutes or so. Of course, in Turkey, they are a little bit bigger than that. In Turkey, they are like basically a super app. So in Turkey, you can rent a car, you can apply for jobs, you can do groceries, quick grocery shop. You can do the long-term ones that takes a little bit longer to get delivered. It's not like in 20 minutes, but maybe in 1 day or 2. They do Getir Food. Getir Food is something similar to Just Eat, for example, or Uber Eats. So yeah, that's basically what they're currently doing.
Okay, and what's your role inside the company?
Oh, absolutely. I'm a senior platform engineer. So as a platform engineer, we have to look after the whole infrastructure, managing Kubernetes, services within Kubernetes. We give support for more than 1,000 developers. And also bring automation to them, implementing Terraform or any other type of automation, trying to remove toil work from their process. We do some SRE as well in terms of monitoring all the services, providing automation for team get onboarded in our monitoring systems, and so on.
Fantastic. And how did you get into cloud native?
Yes, nice question. Actually, I got into cloud native when I was, getting into my journey with Kubernetes. So I think I started focusing on Kubernetes. I started studying, preparing myself for the certifications. The first one I got was Kubernetes developer, application development. And because of that, I started trying more with Kubernetes, bringing this to the company I was working at the time, and I started getting involved with all the other tools to support the company needs at the time. Things like, for example, Cert Manager to acquire TLS certificates, grade A+ for free, ingress controllers as well to deal with the ingresses, the exposure of our services to the public internet, and so on.
And what were you before cloud native?
Before cloud native, I was mostly software engineer, coder, focusing on. I think at the time they were doing the core. They were still developing, but they've been working on .NET and C#, even previous before that. But basically creating applications, product development applications for the companies I was working at the time.
Now, the Kubernetes ecosystem moves very quickly. What are your go-to resources? Blogs, YouTube videos, podcasts? What do you prefer?
Yeah, absolutely. I prefer a little bit of everything. I try to get things through Pluralsight, for example, or such platforms where I can get some video classes. Also going through the Linux Foundation, applying for certificates or at least their trainings, and reading articles a lot.
If you could go back in time and give your previous self, any kind of career advice, what would it be?
I think I would have taught myself. I would tell myself to learn a different language at the time, because I think learning and improving, let's say, in other different languages can open your mind to adapt and change with this current IT landscape we live in. So I would go back and tell myself to grasp different languages, get very good at them, and I would go from there.
Okay. Now, as part of our monthly content discovery, we found this article, The Challenges of Configuring Kubernetes Resources, Requests and Limits, and HPAs at Scale. So the following questions, we're going to be diving into this topic a little bit deeper. But before we get into the crux of today's episode, can you tell us a little bit about the cluster configuration at Getir?
Yes, in Getir we have two main environments. We have development environment that contains about 146 namespaces. It can vary here and there. It's not a very polished environment because teams can go and add a different namespace, so we don't have much governance on there. And the workload also can vary. Right now, would say about 2,200 plus workloads. Second biggest one is production. We have about 46 namespace. This is the most importantly. The workload there, of course, drops a little bit. When I mean workload, I mean deployments, stateful sets, daemon sets, etc. it drops a bit because the production environment. So there is no much, let's say, researching being done there. There is not much try and error being applied there. So we have a little bit less. I would say around 797 workloads. With and adding to the replications, it can go to more than 8-9K pods in a specific moment in time.
Okay. And if we're thinking about, infrastructure, what are the biggest challenges for infrastructure of this size?
Well, one of the biggest challenges is to keep it always on, to ensure the cluster is fully operational and avoid outage. And when I say fully operational, has to be with all the services that are running there, not the product the development applications, because this is the responsibility of the tribes and squads that tackle specific needs of the business, but more to ensure the cluster is there for them to use all the time, and also manage stakeholders' expectations regarding the cost, utilization, and rollout of new features.
And how do you keep over-provisioning under control?
Well, over-provision is a very interesting topic, and that's the reason actually I wrote the article. As part of working at Getir, I had to focus on an initiative of cost reduction. And one way of reduce costs is looking at our Kubernetes cluster and trying to ensure that we make the best usage of our resources, mostly memory and CPU. And for that, we have to be very conservative sometimes, and very aware of how we consume that, how we request that. So one quick way to doing that is, ensuring your requests contains conservative values in terms of the actual needs of your application. And to learn that, we can use monitoring tools to identify how much actually our application uses, and we can try to improve on there. And when I mean requests, I talk most about the request itself, because request is what Kubernetes uses to schedule market pod to be scheduled in a specific node. And that request is also the chargeable, let's say, the chargeable units within your cloud provider, either GCP, Azure, AWS, and so on and so forth. So we have to be very conservative in how we choose those metrics and values for them.
And in terms of advice that you would provide, how does someone set requests and limits to avoid so as to not over provision? Should they underestimate the CPU and memory they need for their workloads? And what are the consequences for that?
That's a good question, Bert. But is a very difficult one, to be honest. It all depends in many, variables. In a small organization with specific number of machines with a known amount of CPU across those machines, and a known amount of memory across those machines, would be a little bit easier to deal with than in a highly distributed, ever-scaling environment, or in a Kubernetes that has thousands of pods running concurrently. With, for example, Getir in production, I think in a good time, in a good day, you can find about 500 nodes, 500 VMs running to support the workload we have. So managing resources on that specific environment is way harder than in if you know a little bit more and you're a little bit more static in terms of scalability for the nodes. And also Kubernetes always schedule your pods based on the requests the requests you set. So in a small environment, setting a lower request, in a small environment, knowing that your nodes are large enough to deal with the demand, setting small requests is okay, because then as long as you don't have a limit or you have a large amount of limit for that specific workload, your application is going to work nicely. Yeah, you're going to get more resources you need, and you don't over provision that much. In a large application, let's say cluster, being very conservative on the request can be a little bit painful, because you don't control the amount of workloads, amount of pods that are going to go there. Other teams are also deploying at the same time as you're deploying, and that can get difficult. And requesting very little can eventually cause eviction of your pods, because or either the node that the pod was scheduled initially is running out of memory, or maybe the CPU as well is being consumed by being shared by other workload, other pods from other teams there. So it can be a little bit tricky, and eventually can suffer some eviction. Of course, under provision also comes with lots of consequences. It can affect your application, let's say performance. So you can have some performance degradation, increased downtime, resource contention. That would be other workloads will be fighting for basically that same resource, and this could create a bottleneck there. Also scaling challenges with your workload. So it's a very difficult to say, but there are ways to overcome a little bit that. We can discuss, I guess, a little bit further.
Okay. And if someone doesn't want to go over or under the provision, let's imagine they find the right value. Isn't that outdated as soon as there is a code change?
It depends, not necessarily. Code change might not influence on how the application is performing and how much resource the application is consuming. But it might be as well. Depends if it can be a bug that deploy some change in the system, that system has some bug that is consuming too much memory. Is probably not cleaning the garbage collector. You're having long-lived objects there that the garbage collector is not collecting, because depends on the specifics of your language. For example, C#. I could have this problem where some long-lived object would be there and would be promoted from a stage of memory 0 to 1 to 3 to 2, and that would be there, and that would consume more memory. So it depends, but the best, I think, is configure good amount of requests, being conservative, and depending of the criticality of the application that you're deploying to. You're deploying to the cluster, and then you can apply other things on top of that to, let's say, help you out scale your resources you need. One thing could be, for example, you could use a HPA that would be scale out. So technically, that's a single pod would be requesting the same amount of requests, but then you have a second pod. So you double the amount of workload that can be processed. Another option would be VPAs. VPA is a vertical pod autoscaler. It's not part of Kubernetes as HPA is. HPA is actually known as Horizontal Pod Autoscaler. The Vertical Pod Autoscaler comes as an external controller that you can install within your Kubernetes, and then it's going to increase vertically the amount of resource you need. It can be memory, CPU, GPU, and so on. And on top of that, if you're using Kubernetes above the version 1.27, there is one thing called in-place resizing, which is basically a policy that tells Kubernetes how to deal once the specific request of memory or CPU or GPU changes. So normally, prior of that, any change of request memory, CPU, GPU, whatever, would cause the pod to restart. Or actually not to restart, but the pod would be evicted. Another one would start in its place with that new value. But with in-place resizing, you can let Kubernetes know that you don't want to restart. So the VPA could do the change for you from, let's say, 300 megabytes to 400 megabytes, and that pod would then restart. So that pod stayed there, and that wouldn't would cause any downtime of your application or slowness because one pod is being replaced by another, and so on and so forth. Of course, there is you have to take in consideration how you do this replication. And we can put some policies as well to only allow a specific amount of pods to go down while it's being replaced by a new, let's say, state. But yeah, it's very tricky. So we have also to keep in mind what's best for you and trying to understand what works for you.
Is there any way that people can be more proactive with their requests? Would your advice be to change them and reevaluate them frequently?
There are many ways, but also it has drawbacks. Of course, you can do this manually, or you can use, for example, KubeCost or resource allocation tool I mentioned very early, or any other monitoring tool to evaluate the amount of resource you're consuming. And based on that, you can make changes. You can make change manually, you can make change automatically using Horizontal Pod Autoscaler or VPA with memory in place resizing. Or you can also use some tools to automate that for you. So you don't have to worry about doing that yourself. Or you don't have to worry about enforcing all teams to create HPAs or VPAs for that. And it also depends on the size of your organization. Sometimes asking development teams to please create a HPA or please create a VPA with in place resizing might be a little bit difficult, and they might not respect, or they might just miss out the point. So as a high level, it's difficult for you to control that. So having something that does this automatically for everybody is best than try to enforce such a process. Of course, the process is good to be there, maybe providing those ideas through code governance, but having an automated mechanism I would say it's better. And tools like, for example, KubeCost Enterprise Edition, it can help you out on that. Or StormForge as well. It's a tool that can allow you, can analyze your, let's say, load, and it can change things for you on the go, on the fly, automatically. Of course, it has some drawbacks because, for example, if you have Argo CD on your environment, and Argo CD is looking after deployment of your applications, using this GitOps model, it can be implemented because Argo does reconciliation. So when it changes in the actual cluster, it is gonna be a drift from the actual GitOps, let's say, principle, where your source code is the source of truth for the state. So your pod, your source code is saying, I have this amount of resource, but such automated tool went and changed that for you. A reconciliation to like Argo CD or Flux might bring this state back to what it was before, and is counterproductive. So you're trying to solve one problem, but the tool is another tool is not letting you go. So it has its drawback. Of course, you can disable such reconciliation for specific workloads, and disable for everything, or at least for critical applications. And you let some automated mechanisms do the rest for you.
Do these tools only help with memory and requests?
KubeCost, not really. KubeCost is focusing on other takes like disk utilization, GPU utilization, and let's help you adjust on those. StormForge, at the time I got contact with Dan, was mostly CPU and memory. I'm not sure if this has progressed since then. But there are other tools in the market as well that can help you with the same, and they might have different focus.
So with that in mind, are CPU requests and limits different from memory? Anything that people should keep in mind related to this particular aspect?
Yeah, it differs a bit. Differs in how, let's say, Kubernetes deal with the requests and the limits. Of course, CPU requests and memory requests are basically the same, and they are used in terms of to identify where that specific pod's gonna go, which node has enough resource to allow it. But in terms of limits, it can change a little bit because Kubernetes is gonna use Kubernetes is gonna use one thing called CFS, that's completely free scheduler, to enforce the CPU CPU limits. And what can happen is eventually it's gonna throttle your CPU utilization. And what does that mean? It means that, for example, if you have a service that spin up 10 threads, and you want to process that concurrently, that 10 threads gonna be it's gonna be split. Split in the amount of CPU you have. For example, you have one CPU limit, and you create those 10 threads. So each thread is gonna consume 0.1 unit of that CPU per second, per amount of time. So that specific thread is gonna consume that amount of time, and then the next thread is gonna be processed. So the first one stops and keeps going. Each thread gets processed one after the other. And the very first thread is just going to get processed again at the end of the process time of those 10 threads. So let's say it's going to be, if you're talking about one thread's process per second, so that first thread is going to be repeated again on the 11th second. So you can have some, let's say, suffer some performance degradation there, and this can affect, let's say, user experience, can increase latency, reducing efficiency, and so on.
So could someone use KubeCost and StormForge to estimate the right value and amend their deployments? What's not clear perhaps to some folks is just how quickly you can do that. Is there a better way to manage those requests?
Yes, there's better ways to do it. And we highlighted them a little bit in the beginning when we were talking about Pod Autoscaler. But also, there is never one way of doing things. Of course, KubeCost and StormForge, they're really nice to help automate things, but they might not, the response time might not be ideal for your needs, because StormForge uses machine learning, for example, to analyze the metrics, and it processes that every 15 seconds or so. So until it applies a change for you, it might take a little bit of time. Maybe implementing Horizontal Pod Autoscaler in your cluster, or even VPA as well. That Vertical Pod Autoscaler can help you out on that. The HPA is going to control how your application is going to scale horizontally, and you can set this. There's several different flavors of configuration that you can add. And of course, the basic ones would be, let's say, resource. And when we talk about resource, we talk about memory and CPU and GPU and so on. So we had to find what works best for you. You can come up with custom, let's say, metrics to scale, but we can deep dive a little bit later on custom metrics.
Yeah, with that in mind, how do you set the horizontal pod autoscaler? What metrics should it track to scale the number of outputs?
Okay. You can send your horizontal pod autoscaler in many different ways, I mentioned previously. Once we're talking about resource as a type of metric, we can set that specific resources, memory, CPU, and GPU, to use a specific measure to allow the HPA to scale up and down. Normally, they have three types. One is utilization, that basically deals about average utilization. So it's an average percentage of the total utilization across whatever number of pods you have. Can be 1 as it's beginning, before it's just beginning of scaling, or 2 or 3 or so on and so forth as it goes scaling. You can have average value, which is also is the average value of the amount of resource you ask, and you can have a more, let's say, static type measure that would be a value. So you can say, I want my HPA to scale every time the pod goes to reaches 300 megabytes or 400, or whatever works best for you, depends on your load. But you can specify the specific, more static value, and then the pods are going to scaling. We're going to start scaling as it goes. Of course, there are some other things that you can consider, and you can consider how those how the pods scale. HPA brings one thing, that's scaling behavior. So you can tell how you want to scale that workload. We say, let's say, for example, we provision the pod or a workload, and we say the memory request is of 300 megabytes, and you create a HPA for that workload to scale that specific workload, and you say that you want to scale that at 7%. So once that specific pod, the runtime utilization, memory utilization of that pod gets to that 7%, in our case it would be 210 megabytes, that pod's going to scale. So you're going to have a second pod. And then the load is going to be distributed between those two pods. And if you keep scaling, as long as you keep achieving that 7% of the whole, your application is going to keep scaling. And what you can implement in place as well to help you out better manage that behavior is this scaling behavior through policies that you can configure how you want to, for example, if it's scaling up, how you want that to scale down, for example. Or do I actually want anything to scale down? And so on and so forth. But coming back on the amount of memory you're requesting and the amount of the percentage you were asking to the HPA to scale to, and how this influence on the over provisioning is the best. I think the best is always keep in mind do some profiling, for example, before you deploy. Do some memory profiling, CPU profiling, and maybe in your environment or in the dev environment, where you can learn how much your application runtime would consume, and based on that, you can initially configure the requests of the application to specific amount, more conservative, and also you can tell HPA that you want to scale in a later phase. You can tell HPA also to scale it doesn't have to be below, if you're talking about average utilization, it doesn't have to be below 100%. It actually can be 100%, can be more than 100%. So you can let your application scale a little bit in a later stage. Depends on the criticality of the application, which type of application that is, and so on. So you can configure HPA to help you as much as possible in terms of trying to, let's say, over provision and overpay resources as much as possible.
And how does the HPA help with over provisioned replicated workloads?
Yeah. If well set, in combination of what I mentioned before with a conservative, let's say, initial requests, HPA might reduce the amount of over-provision the resource you will request. As I said earlier, you can request, you can configure HPA into scale more than 100% in case of average utilization. Or if you go to average value as well, it can help you out to configure a better, let's say, amount. So earlier I gave an example of 300 megabyte pods with average utilization of 7%, but let's change this to average value. Well, and let's say that actually your pods initially, when your applications are running, it consumes approximately to that 300 megabytes. So it's okay. Initially, it's working fine. But, and you're not over provisioned right now, but as it goes, its scale, you can configure this average value to be or a little bit more. Let's say you don't have limits, but your application consumes the 300 and you don't have limit. And you can tell it to HPA to scale application when starting getting maybe at 400 megabytes or 500 megabytes. So at least we're a little bit closer to the initial need of the application that we had there. And you don't over provision that much. You don't over provision much your resource. We can also use values, which can help you, come up with, that's not average anymore. The value itself is a value per pod. So every time that the specific pod gets to that specific amount, let's say at 400 megabytes, initial pod of 300 megabytes configured for HPA to have 400 megabytes. Every time that each pod gets to that specific amount, it gets a new one spin up as long as it respects the maximum value of the HPA. So you also have a little bit more control on the amount when you wanted the HPA to trigger, and how much you wanna for how long you wanna let the application scale grow internally in terms of the memory that's consuming. And two is you get a new policy to process that the request. And of course you can configure the policies, scaling policies on the HPA to improve how you to help you in how you scale up or how you scale down, or how things keep going after a specific amount of time.
But isn't scaling on memory and CPU always a bit fiddly? Let's consider the following scenario. You have one pod with a memory request of 1 gigabyte and an average utilization of 70%. So a new pod is created when the actual memory usage is more than 700 megabytes. Imagine you drive some traffic for the pod. The memory reaches 800 megabytes and the HPA triggers the autoscaling and adds one more pod. The traffic is now split into 2 pods instead of 1. The actual memory consumption is likely to drop as well. If it drops below 700 megabytes, the second pod will be removed. This will make the single pod receive all the traffic, increase the memory, and trigger the autoscaler again. How do you solve this?
I think the best approach for that is to have that scaling behavior policy, because there you can tell the HPA not to downgrade. There is a maximum amount of time that it can respect that is 30 minutes. You can tell HPA not to scale down for up to 30 minutes. Or actually, you can tell a percentage of how much it can scale down. In this case, you give a very simple example, one pod that scales to a second one. Increasing the amount of time that the second one could be alive might help you out on not scaling the second one down immediately. But if you keep getting more pods, you can let Kubernetes know that you want to adjust a percentage of them to scale down. Even, let's say, the amount of the average, it's way below, you will reach 4 pods, but the average utilization, it's way below, it's just enough to support, maybe 2 pods enough to support that. So those 2 other pods that are alive, they might eventually be evicted. You can let HPA know that you just want a specific percentage of those pods to be evicted. So you can say only 10% of those pods can be evicted, or 20, or so on and so forth. So you can control a little bit better how it's going to scale down. Of course, it also works for the scaling up. Policies, utilization policies in HPA can help you with solving this specific issue.
Until now, we've discussed the technicalities of setting requests, limits, and the HPA. But I think it's fair to imagine that you've also must have faced another pretty significant challenge, which would be adoption. How did you convince the rest of the developers to inspect and use the right requests and limits? And what are the incentives, if any?
Yep. Adoption is always a complicated matter. It also depends on the sense of users created by the leadership teams, high-level stakeholders, and also organizations' financial challenges. For example, Getir, I faced this challenge for sure, and the idea, the goal was we had to discuss a reduction initiative, and we had to engage with teams to deal with reduction of costs. So I think the best approach is for you try to start small. try to create some coalition, or let's say advocates that share the same idea as you, share the same, let's say, same problem as you. So they also wanna be more sustainable in how they spend their budgets in terms of cloud resources. So finding those and let's say these individuals or teams is very important at the beginning, and also creating a sense of urgency to tackle this challenge, to face the problem as soon as possible, and create well documented, let's say, pages and process where it can help teams to adopt that change a bit quicker. And I always start with one team, one tribe, and then we keep going from there. Of course, if I'm saying this in the sense of not having automated lots of the work, as just more mentioned these challenges like that. Let's get these people, the developers, to use HPA or to use VPA to better configure the request resources. So it's a little bit more manual process. But of course, if you have you want to automate that, I think the same steps go through, because then you have to homologate an automated tool. You have to get that approved. Some tools, they cost, so you have also to manage the budget for that. For example, StormForge, it charges for the amount of resource per CPU that they bring down for you. Even actually KubeCost Enterprise cost. So if you want to implement something that you're going to come up again with the same challenge of adopting and implement that, but I think the same process follow. I think using the quarters, it's steps to change model can help a lot on that initiative.
If you were to do it all over again, what would you do differently?
I think, I would spend more time on automation. We spend a lot of time on trying to get people on board in terms of improving, educating them on what's HPA, what's VPA, manage with actually VPA and controller in Kubernetes, document it, but trying to automate this from the beginning might be a best option. You can even create your own, let's say, controller to do that. If you are, let's say, if you have enough time, and you could install that to your Kubernetes and let things go based on your needs. All Kubernetes service there you can consume, and you can know about your cluster, you can know about the amount of resources consuming. It always can be done, but automation, I think, is the best way to go. Well, I think I would focus more on an automated tool for that.
Just to wrap it up with our last few questions, you're the founder of TechMeOut. What is it, and how did you come up with the idea?
Yes, I'm one of the founders of TechMeOut. TechMeOut.io, it's basically two things, but always with the same goal. We are trying to improve, come up with some nice ideas in the recruitment process. So TechMeOut.io is a free version of one of our ideas that allows you to build your CV, give you highlights in how to improve your CVs and how to improve the sections of your CVs. We give some scores as well to you, how good your CV is. We provide tools, AI tools as well to improve your writing. And at the end, of course, the biggest outcome is have a rich CV that you can present to organizations when you're trying to find a job. Our initial focus was on tech professionals, but we're expanding that. The second part of TechMeOut is the B2B part. That's for recruiters. So recruiters can manage the whole hiring process to invite candidates, collaborate with them to improve the CV, collaborate them using also our AI tools to improve the CV. And the last stage would be offering that candidates to the hiring managers, to companies. And the main goal is to provide the best chance for the candidates to get the job at the end. And we came up with this idea. Actually, this idea was initially from my friend Gabriele. He experienced many issues while hiring people at eBay. Lots of, let's say, not standardized CVs, poor CVs, and the idea was for us to come up with some tool that can standardize CVs, the look and feel, and even the quality of writing on those CVs, so they can get a better chance. And
What's next for you?
Well, I guess now it's keep focus on Kubernetes for sure, but not only that, focus on continuous delivery, DevOps practices, and try to bring better ideas in how to improve the development lifecycle process in companies that I've been working for, and improve operational organizational performance as well in those companies.
And if people want to get in touch with you, what's the best way to do it?
You can get in touch with me through TechMeOut.io, where it's a very simple way. Just mention that you heard me on this podcast, and then I can contact you back, or through my bio site. That's on bio.site/AlexZ Souza, SOUZA. Through there as well, you can find my LinkedIn profile and X account and so on.
Fantastic. Alex, thank you so much for your time and sharing your knowledge today. Look forward to crossing paths with you in the future.
Thank you very much. And I hope I answered your questions. And I
You did a very, very good job. You did a very good job and lots of details. I'm sure our listeners will love it. Thank you.
Okay. Thank you very much.